Hello and welcome to another video. Today we have a B450 AORUS Pro Wi-Fi on our bench. This board came from a viewer, and the viewer said that this board booted once, went into preparing devices in Windows and shut off and never turned on again. So yeah, this is what we know for this board. He has bought this proposedly working. So I'm interested in what actually happened to this board. So I would think that there's nothing shorted on this. So let's try to power it up and see how this board will behave. Let's get the postcode analyzer or the DDR postcodes into here. Let's get a stick of RAM into here. It said on the box it's Ryzen 3000 ready. Don't know if that means it supports also the 3300G, the 3000G, which is an APU, because it does have display outputs. So let's see if we can already see something by the power consumption of this board. So let's get the box out of the way. This is an insanely small mainboard, like really small. Cool form factor. These are also very expensive because they're that small. But yeah, let's see now. Let's put also a speaker onto here and the power button. So let's see for the passive power consumption. 130 milliamps. That looks very good. That looks how I would expect it. Let's see now. Reaction to the power button, but almost no amp draw. Does it turn off again with the power button? No, it does not. So let's turn it off again via the power supply. Turn it on. And we have the passive power consumption looks very fine. But I now hit the power button and we go to 300 milliamps, which indicates to me that there's some major voltage rail not running. So that I would guess it's probably the 5-volt dual or something that wouldn't be running then. Because this is one of the first major rails. Let's see again. Yeah, with the different CPU, this is the 2200G, same thing happens. I want to know if we have the major rail voltages, if they get onto this board. Because the power consumption is really low, like exceedingly low. Let's see, 3.3 volts. I think this should be 5 volts right there. 12 volts, okay. Let's see, and this is, I think, 5 volts then. Yeah, 5 volts. So all of these are present. So what I would expect now, on these very small boards, they get built up in very small cases most of the time. Which means that people knock off components off of these all the time. This wouldn't really fit to the description of what the owner said, that this board booted once and then never again. But let's see. For these, I will have to remove all of the heatsinks. Most of the time, like for example, removing the VRM heatsink is not necessary. But in this case, these boards are so densely packed with stuff that you will have to take off basically everything and inspect all of the areas in order to find out if something is missing anywhere or got knocked off. So the board is now stripped down of its components. All of the heatsinks are off. Let's now go under the microscope and see for any physical damage. I would especially think of physical damage on the backside of this board, because they are also very densely packed on the back, and that is where most of the damage occurs. So let's go onto the backside first then. Let's do that. Let's go under the microscope and have a look together. So let's see now. Don't even know where to start because there's so many components on this board on the backside. And it's really densely packed. And most of the time, I know what area is responsible for what. Like what kind of components you have where and what they're responsible of. But on these small boards, things are very different. They just, if there's space to fit something, they will put basically anything there. Because they have stuff to fit somewhere, and they just use whatever space they get in order to get these boards as small as they are, with as much features as they can have. So nothing there so far. So far I gotta say this board looks very clean. Let's see here, another densely packed area with a lot of passive components, but mostly filtering capacitors. This is for the PCIe. Nope. It seems to be fine. So no obvious damage on the backside, which I would have expected. But let's check the front. So, most obvious places is where we have connectors and screw holes. So let's have a good look at those. In this area, for example. But looks to be fine right here. No obvious damage. Let's see, top right corner. Also looks fine. Around the 24 pin. This is now the front panel. Some SATA. USB 3.0. Fan connector bottom right screw hole. So PCIe latch. Let me see. This is always a little bit hard because you will need to look under it at an angle. They love to put components under the PCIe latch. Which is truly horrendous if you ever have to work on these components that are here. But it looks to be fine. Oh, there's more components there. But they also seem to be fine. Let's see, PCH area. I don't think that the PCH heatsink was off at any time. So don't think that there will be any damage there. Let's see, this is now the CPU socket. This is also an area that gets damaged all the time. And the other mounting screw or mounting hole. Again, close to the CPU socket. Nothing here, okay. Let's look, this is probably the PWM controller right here. Going at the SIO now. BIOS chip. Linear voltage regulator, probably for the SIO. This one right there. Another BIOS chip? Oh. Good question. Is this backup BIOS or is this something else? Yeah, main BIOS and backup BIOS probably, yeah. So this has Gigabyte's dual BIOS solution that has worked awfully sadly. I've had so many boards with the problem with this dual BIOS setup where it just didn't work, where both BIOSes were just corrupted. At the end, it didn't help at all. And I gotta say, this board looks fairly clean. No signs of physical damage at all. Question now is, we will have to check for voltages probably. Which of our voltages are running and which are not and why. Because 300 milliamps is just nothing. That is like, there's nothing running on this board basically. Even wonders me that it even reacts to the power button with that, afterwards having that low of power consumption. So let's get the power supply back connected onto here. And let's also get a good ground. And with having a ground, let's now go over some voltages. Let's zoom down and have a good look. So let's see the power consumption and the multimeter. And let's see now. Power button is needed. So turning it on. Okay, let's check. I will need sharp probes for these inductors that I used here. Right there. 1.8 volts is running. Let's see for this one. Can I get onto here? These inductors are really hard to probe. No idea. This is just a 12 volts incoming. 0.9 volts. Okay, we have 1.8 and 0.9 volts. Okay, let's continue our search. Let's see, what do we have here? 2.5 volts. VPP is running. What do we have on this tantalum here? 3.3 volts. That seems like 3.3 volts VSB. What does this inductor say? This is a 12 volt inductor. Okay. This tantalum polymer here, 5 volts. So 5 volts is also running. Okay, let's see. What does this one say? VDDQ? No, also 5 volts. Okay. This one? Also 5 volts probably. This one is behaving weird. What is this one supposed to be is the question. Is it my probing? Let's see. Yeah, it's my probes. This is 5 volts. Let's see, there's a big inductor that I think I cannot probe. Maybe I can probe its corners. No, cannot probe that. Cannot get a good... We will have to see what this inductor is for, this top one. Because I cannot probe it. Let's see for this one. This is a linear voltage regulator. Gets a little bit warm. 3.4 volts. That looks fine. Let's see. Can I get... Yeah, we don't have V-core, obviously. So that is not running. So let's see on this, the linear regulator for the SIO probably has 3.3 volts as expected, because it does react to the power button. So there are voltages definitely running on this board. I would want to clear the CMOS on here and also see for different CPUs if they have a different reaction, and also see for what CPUs are supported on here. Let's get a look at the BIOS battery. What kind of voltage we have there. Let's see now on this pin. I just saw 2.8 for a moment. This probe is just awful. 2.9, so kinda low. Let's pull it out. Let's do a clear CMOS right there. There's a header right here. So we just pulled out the BIOS battery. There's a clear CMOS header right here if my camera would want to focus. There we are. Clearing the CMOS. And let's now see again if we have a different reaction. No, same reaction. Let's see. I just want to put RAM in just to be sure. But I don't think that there's anything happening so far. Anyways. Yeah, there's nothing happening anyways. I don't know where VTT DDR is. That is a 0.6 volts signal, or 0.65, that is often responsible for enabling the V-core. And it is derived from VDDQ, which is 1.2 volts from the DDR. This is just part of the power-up sequence. And let's see. Let's get the DDR tester onto here. And let's see now. It seems like we're actually missing some voltages. So SPD is present, VPP is present, but VDD, so the 1.2 volts for the DDR seems not to be present. That might be our issue. Let's change this slot again to the next one and see if we have the same behavior here. Yeah, same behavior. VDD is missing. So VDD is VDDQ in this case. This is the 1.2 volts for the DDR, for DDR4. This is like the main supply voltage for it. Question now is, where is it located? And I would guess that it's probably the big inductor right there where we didn't get any voltage. So let's go under the microscope, see for this area again. And we might want, yeah, let's look at that area, and we might want a board view to see where VDDQ is being created from, if that is the correct one. But let's first go under the microscope. So this is probably the VDDQ area where it's being created. And the question is this its controller, RT8120D? So is this a MOSFET driver that drives these two MOSFETs to create VDDQ is the question. It might be. Is there components there on the backside? There is components here on the backside. So let's see here. We have been over this area, but it looked fine. I would be interested if there's a voltage on this MOSFET right here. Let me turn it on, get a ground somehow, and see if I can probe that. And let me turn that on. So at the 300 milliamps now. Let me see, can I probe this MOSFET? 5 volts. Okay, so the MOSFET has 5 volts. So it's time to go into a board view and see how VDDQ is being created and why it's missing on this board. Now we have reached our board view, and let's see now if this is what I meant. DDR 1.2 V phase. This is pretty sure that this is what we are missing, the 1.2 volts. So let's see. This comes from these ones, from these MOSFETs, and let's see their gates. Where are they driven from? There's a 2.2 ohm resistor. Let's see what's on the other side. On the other side of the 2.2 resistor is that controller. Okay. And on the other side of this one is also that controller. This is a feedback loop. Okay. Yeah, so this is just a feedback thing for this gate. And from the other one, the lower gate, let's see, there's the same thing again, probably a 22k ohm going to ground. Oh yeah, and this one is just directly connected to this one. Okay, so we will have to take a look at this controller then. Let's see. This has a VDD-IO enable signal, which is pin 7. Where is that coming from? That is on the backside from a N-channel MOSFET, a capacitor, and a 60.2k ohm resistor, which just has a signal on it that presumably leads nowhere, just to a capacitor to ground. Okay, so we will have to look at this one then. VDD-IO enable, if that is present. So let's go onto the backside and see on this N-channel MOSFET then, if we have the enable signal here. So this should be our MOSFET in question. Let's try to turn this board on and see if we have voltages on here. Let's see, is this a good ground? So this should be the enable signal if I'm not wrong. 1.3 volts. Okay, this is kind of low. 1.3 volts. Is there 1.3 volts everywhere? Here? Let's see if I can get a better ground maybe. Maybe that is my problem. Let's also put the probes on the right way so we don't get a minus reading. So on the output I don't seem to get anything here. Let's see right there. Come on, probes. Don't let me down now. Okay, so my ground is good. And I don't get anything on its output. Does this pin have anything? No, it does not. Let's get some focus into here so it looks better, like that. Let's now probe the lower part. This has also no voltage. So no voltage anywhere? Yeah, none of these pads have any voltage. If we go on this one, for example, yeah, this has 5 volts. There's the MOSFET next to the regulator, like this one. This one has 5 volts, so my probing definitely works, as you can see. But on this MOSFET for the enable signal, there's just nothing. Nothing here. Nothing there. For a short time, it seems like there's something, but there is nothing. And also here, nothing. Okay, did we just have no voltages? Okay, then. Let's then have a look at the board view again. So, let's try to analyze the circuit a little bit more. We know on this output, we are supposed to have 3.3 volts on this enable, or like 1.8 or something like that. This is the 5 volt that we saw before, yes. Okay, let's see. This is the enable signal. It is connected to the controller, to a capacitor, to one resistor, and to that N-channel MOSFET. As we saw, that resistor leads nowhere. It's a 16.2k ohm just to another capacitor, and that's it. This just goes to ground. There's nothing more. Can't tell you what that is for. Then we have this this N-channel MOSFET. This is a 2N7002. We have ground on the upper side of the board. Then we have the gate signal right here. I think this should be the gate signal. MAQ72. And let's see where that is coming from. That is connected to this capacitor and to this capacitor, but those are both not fitted. Then there's an 8.2k ohm resistor located at the bottom right where the PCIe slot is. And then there's two more N-channel MOSFETs. One here and one down there. And important is that this one is supposed to be connected to 5 VSB. So we will have to check let's check this area first here. So I've now removed our PCIe clip, so we have a better view at this area. And so far it looks to be fine. I cannot see any physical damage. So let's get a ground hooked up again and see for some voltages on here. So oh, the board is still turned on, okay. Let's see now. So we are in voltage mode, and let's see. This should be 5 VSB if I'm not mistaken. But I do not get anything. Let's check if my ground is okay. And I don't seem to have a good ground because I don't see any voltages. So let's see now with a better ground. We have 5 VSB here. We have nothing here. 5 volts there. Nothing here. And nothing there. So this output does have 5 volts. But none of these have any voltages. So let's look at the other area, which was right here, and it was probably this one. I think it was that one. Let me quickly have a look which of these transistors it was. Yeah, it's that one. So on this transistor right here, we have nothing there. We have nothing here. And we do have voltage there. So this is probably the gate, and it's powered, which means it's pulling the output down to ground. So back to the board view then again. So let's analyze what we had. We had 5 VSB here on this part. And on this we saw nothing anymore after the resistor. So this is just a capacitor that is not fitted. On this one it's the gate. I think this is the gate. Yeah, this should be probably the gate that connects 1 with 3. Let's then see here. What do we have on this one? We had only voltage on this pin. Question is now, let me quickly have a look which pin is which on this N-channel MOSFET. Yeah, I just had a look. This is its gate. And currently, it seems like the gate would be powered, that this and this is connected, so that 2 and 3 are connected here. So source and drain is connected. But it doesn't seem to be that way. Weird. We will have to see if this line is shorted to ground. Oh, this is... Wait, why is this VPP enable? Am I on the wrong... Hold up a minute. We were looking at VDDQ enable, not on VPP enable. Where's that? We were looking here on this VDDIO enable. Right, and we went to this one. And the question now is, why is there no voltage here? MAQ7. But we don't want voltage on this. If we have voltage on this pin right here, we would have gate and source connected to each other, which we don't want. But where is the VDDIO voltage supposed to come from? I don't get that. Because, have a look. This is the controller. The next connection is this capacitor, which just goes to ground, obviously. We have that N-channel MOSFET that is not being powered, which is good, because that means our output isn't pulled low. And then all that there's left is this 16.2k ohm resistor. But this resistor only goes to this capacitor. Where's there supposed to be voltage coming from for the VDDIO enable? Let me spend some time looking around the board, because this is weird. I'm not too sure where there's supposed to be voltage coming from. So it took me quite some time to figure out how this works. This chip is always enabled. This chip only gets disabled. So you only have a disabled control. By default, it's always enabled. And you can see the exact same circuit that we have here. We have a resistor in series with the capacitor connected to ground. We have then another capacitor that's just straight up connected to ground. And we have one MOSFET that is connected to ground. Which means by controlling this enabled signal, the gate of this MOSFET, you can pull this permanently low. And so you can only disable this chip. This chip will always be enabled. So we will have to look further. Let's see if the VCC is present on this chip. And try to figure out why it isn't working. So now at our controller, let's see. Pin 5, which is this one, is supposed to be 5 volts. Or 12 volts in this case. It can also be 12 volts. So it does have its voltage. This is the pin, the enable pin, that is always high except if it's disabled, which it is not in our case. That has no voltage. That has no voltage. Let's see. This has nothing. This has nothing. This has nothing. And this has 12 volts. Okay, we have 2 pins with 12 volts. I want to see if anything is wrong with these MOSFETs that it's connected to. Whether one of these MOSFETs might be shorted. Let's see now. We go here and there. Let's take Ohms mode. 45 ohms. That is probably just the DDR stick. (140 ohms), okay. And from here to there. So the MOSFETs are not shorted. Let's see for the gates, which would be this pin right here. Let's check this with ground. Also not shorted. And this gate right here. Also not shorted. Pretty sure this is the gate. Yep. So I would probably want to change out this controller, because this controller doesn't seem to do what it's supposed to do. I will have to find out if I have that controller anywhere in stock, or maybe on one of my boards. So let me have a look for that. So it seems like we're getting really lucky, because I found on a Gigabyte board Z97, I found an RT8120, just like we need. So we will have a replacement chip that I can put on there and see if that will help our situation. So in order to quickly remove this chip, let's put some flux onto it and get leaded solder on all of the pads, so we will need less heat on this board. And let's now hot air this chip off of here. So chip is off. Took a little bit longer than expected because there's a ground pad on it, which didn't have any leaded solder. So we did have to heat it up as well, pretty high. So let's now get the donor board in here. Can't believe that this old of a board has exactly the chip that we need, but it's just a single phase PWM controller, so it's really nothing special. Right there is our donor chip that we need. Again, adding leaded solder. Maybe this package doesn't have a ground on it, under it. Probably has though. So let's take hot air and blast this off, and hopefully this will be the solution to our problem. So what I like to do to get these chips better on here, I like to just get some of the legs sorted onto there, just somehow, in order to now just be able to blast it with hot air so it doesn't fly away, because it's already partially soldered on. Now it seems like it has gone into place. Let's wait a little bit longer so the ground pad definitely under it is also soldered. But that should be fine. And let's wick off that short that we have there between those two legs. Now we have good connection on all of these pins. Let's instantly clean it up, as long as everything is still hot on the board. A little bit much soldered, a little bit squeezed out the side there, but it should be fine, I think. Right there, it's squeezed out a little bit, but it should be fine. So our chip is now replaced. Let's now apply voltage to it, to the board. We have instantly 200 milliamps. This is a little bit high. Let's see if we now press the power button. But now we have good reaction, and now we have voltage. Now the voltage is actually there that we need. Question is now, is this board already posting or not? Let's get a screen into here. Let's get also a keyboard into here. And see now. Let's see. I might want to reset this board. And I think he also flashed the BIOS on this, so I might need to flash it also on here just to be sure that we have a clean BIOS. Let's reset once. So don't see any post behavior currently. No picture, nothing. So question now is the BIOS correct on here that has been flashed? We probably want to go for a clean BIOS flash on here. Let's see. Let's get a different CPU and try with that. So let's go for like the 2200G just to be sure. But it seems like we fixed our original problem with VDD-Q not being present. But now with the 2200G, it also doesn't seem to get anywhere with trying to post. Let me see if any of my postcards have any reaction in this board. So I do get some postcards right now after I've swapped the DDR into the other slot. Let's see now. Now the power consumption is jumping more. Probably had to reseat the RAM only. Let's see now if we can get a picture. As you can see, yeah, there it is. Nice. Very good to see. So it was just bad seating of RAM right there. We now have picture on this board. Now it seems to work. And all we had was an actual dead controller, PWM controller on the VDDQ. That is very good to see. I learned something about the controller of the state of being like always enabled and only can be disabled. That was something completely new to me. And how did I know that the controller was bad? Well, it had it in its enable signal. It had its control voltages or like its V-in control, its V-in voltage. And at that point, if it's not shorted, it might still be blown open internally. So the chip was broken in this case. And with replacing it, I got really lucky that I had one in stock actually from a motherboard, taking it from a different one. So what I'm going to do now, let's now build this board completely up. Get all the heatsinks back onto here, and then go into Windows, see that the NVMe works, that the Ethernet works, and all of that, and that it is stable. And yeah, let me quickly do that. So the board is now fully built up again. And now we're going to turn it on. We have the heatsink on here. We have the PCH heatsink on there again. I now got an M.2 installed so that we can go into Windows and see that the Ethernet that I've connected is working, and that we also will have some audio. And yeah, there's the boot with 2 sticks of RAM. And let's see now if it goes instantly into Windows. Tries to prepare devices. 5 amps of power consumption won't reset by itself. And now we should, yeah, there it is. And there's the Windows loading. We should be preparing devices probably every second. And get a Windows screen. So I had very weird capture issues with an APU. I quickly swapped out to a normal CPU and got a GPU into here. And now the capture works. So now the board is actually on and seems to be working fine. I have 2 sticks of RAM in here. The Ethernet is being recognized. I currently don't have a audio signal, but I think that will come when drivers are installed. I think they yeah. I also now have the audio. So this board is fixed with that. All we had was a broken PWM controller on the VDDQ phase. So the 1.2 volts for the DDR. That is very good to know. So, hope you learned something. Hope you enjoyed the video. I learned something with the enable signal of that one controller. We got pretty lucky that I had one of those in stock on a different mainboard, on one of my donor boards. And yeah, if you enjoyed the video, hit the thumbs up and the subscribe button. Thank you very much for watching. This was Mainboard Medic. Thank you very much and goodbye.